All right. So welcome everyone. It is lovely to see all of you. And I am delighted to introduce our second keynote speaker for EDM 2020. This is Kobi Gal. Kobi's an associate professor at the Department of Software and Information Systems Engineering at Ben Gurion University of the Negev and reader at the School of Informatics at the University of Edinburgh. His work combines artificial intelligence algorithms with educational technology towards supporting students in their learning and teachers in their understanding. I've muted. He has published widely in highly refereed venues on topics ranging from artificial intelligence to the learning and cognitive sciences. Kobi is the acting president of the Israeli Association for Artificial Intelligence, and he's the recipient of a number of awards: the Wolf Foundation's 2013 Krill Prize for Young Israeli Scientists, a Marie Curie International Fellowship, and a 3-time recipient of Harvard University's Outstanding Teaching Award. In my mind, Kobi's excellence in teaching and research go hand in hand. I first met Kobi a number of years ago through a mutual collaborator, and at the time, I was struck by his kindness and generosity with his time and expertise. In the intervening years, whenever I've seen him with his students, he's been a clear champion of their work, and they speak of him as a valued mentor and teacher. His research has been recognized with several Best Paper Awards, including at UMAP 2019, the ACM Conference on Economics and Computation in 2016, and at EDM itself in 2014. So Kobi, we're delighted to welcome you to EDM today to speak about online collaborative student group learning. So I'll turn it over to Kobi, and I'll just note that before this, he mentioned that he's fine with people asking questions in the chat as he goes, and then we'll also have time afterwards for questions. So thanks so much, Kobi.
Thank you very much, Anna, for a wonderful, wonderful introduction. I have to say one of the focal points of my summer is meeting you at EDM each year, and I hope we get a chance to renew this meeting again in person next year. And so I'll try to keep my statements as short as possible so we could have a kind of discussion when I'm done. You guys should feel free to interrupt, quote unquote, and send questions during the talk. And I'll relate to them either while I'm talking or save it till the end, okay? And so let me start by exactly what I mean by collaborative student learning, or CSL. It's a simple definition. It means a group of students who are studying together jointly to achieve a learning goal, whether inside or outside the classroom. And there's a wonderful body of research in educational sciences showing that individuals are able to achieve higher levels of learning and retain more information when they work in a group rather than individuals. They engage each other more. They develop cognitive competencies like skill acquisition and concept learning, but also soft skills like teamwork and communication, which is so critical to the workforce, but is absent from the curriculum of many schools. Now, you don't need educational theory to tell you how wonderful collaborative learning is, right? The first thing that I tell students when they're having difficulties in my classes is to go study with other people, because I keep telling them, I've forgotten what it is to study this material for the first time, and your friends know, they talk to you in the same language, and they give you discipline and they encourage you. And it's a wonderful way to learn. And I recall when I was an undergraduate myself, I would always join a group where there was for exam preparation, where there was a student who was better than me, so I could learn something fast. And also I was looking for a group where there was a student that was a little weaker than me, because I really wanted to feel good about myself for helping. I distinctly remember that. So that's actually an interesting example from my own experience of the benefit of CSL, or collaborative student learning. And computer-supported CSL, it takes this kind of technological layer and puts it on the group in order to facilitate how students interact, to foster dialogue, and to enable knowledge creation. And there are some wonderful arenas that are being developed thanks to the advancement of technology that allows students to collaborate. Let me just give you 2 examples. And my student Nick is researching connected worlds, which is deployed in the New York College of Science in Queens. It's an ecological simulation. Look how wonderful this thing is. The students work together. There's this waterfall that's delivering water to various biomes like jungle and desert. And there's
Kobi, we're still seeing your title slide.
Oh, okay. I see. But you're not seeing a movie?
No.
Okay, good to know.
Bevakasha.
And so I'll take care of that later. And so I'll just tell you that there's a waterfall, and the waterfall has to supply water to these different biomes. There's not enough water to go around, and the students have to undergo this kind of systems thinking. There's a stochastic relationship between water and flora and fauna blooming in these biomes, that's plants and animals, and their goal is to try to make the biomes bloom as much as possible. And to do that, they have to trade off the amount of water that goes into the different volumes and work together as a team. So that's a wonderful example of an immersive simulation that's currently deployed in various museums. And I'll also mention virtual math teams. That is a kind of a wrapper that's put on GeoGebra, which I'm sure many of you know. It's a tool, it's an online wonderful tool for geometry education in thousands of schools worldwide. And virtual math teams gives a collaborative layer to it. Here you're seeing Arab and Jewish students in Israel solving a geometry problem together in a project that's funded by the Israeli Ministry of Science that I will return to later. And so I gave you several examples of arenas for enabling collaborative, one second please, collaborative student learning. I should say that two important conclusions from this literature is that first, small groups are optimal. So you want to get 3 to 4 students working together. And another is the idea of the teacher as an orchestrator or the facilitator. No matter how good your technology is, it can never come in replacement of a wonderful teacher. And that makes a lot of sense to us intuitively, but as you can imagine, it really hampers the ability of CSCL approaches to scale up to the real world. And that's exactly where this vision of what I call AI-supported CSCL lies. So imagine we could take models of student learning and endow them with agents so we can scale up the benefits of collaborative group learning, such that students could be assigned to groups based on their interests and capabilities. They will work collaboratively within these groups. And the long-term vision is to augment these existing CSCL environment. Maybe sharing the screen. Oh, okay, you guys are still talking about the movie. I'll remember for next time.
Kobi, it's actually, we still see just your title slide itself.
That's bad. Okay.
So maybe unshare and reshare your screen.
Yeah. So this never progressed from this title?
It did never progress from the title.
Ouch. Can you see my screen?
Yes, I see the title slide. Do you want to try advancing? Beautiful.
Okay, so let me give you a quick recap to see who's on cue. It's not for the exam, don't worry. So here's collaborative student learning. These are the students that work together. This is me looking for a group where there's someone a little stronger than me and someone a little weaker than me. Now we're putting this technological layer on it, the computer-supported collaborative learning that enables productive dialogue and knowledge construction, right? They're interacting in this wonderful immersive simulation. Can you see the movie now? Okay, Jack is nodding, so I'm taking that as a, and Tiffany, I think this is working. And then here's the, hi Tiffany, and here's the virtual math teams in action that I was talking about used in Israel. And now here's the final layer of AI-supported collaborative student learning, and where the idea is, the long-term vision is to augment the existing CSCL environments with AI technologies that guide students' group behavior, they provide motivation and feedback, and they facilitate teachers' abilities to actively guide and contribute to their learning at appropriate moments. And this is a very important point, right? Because we know that we want to augment teachers' capabilities rather than trying to replace them. So that's the idea behind AI-supported CSCL, and this is exactly the right kind of community to bring that vision to the fore, because the learning, the EDM community, the learning analytic community, we know a lot about large-scale analysis of student-generated data, about working with e-learning clickstreams, MOOCs, distance learning. We have amazing models of student performance that model skill acquisition. We can predict dropouts. We can track the effective states of students and understand how they learn. And so there's a burgeoning literature in EDM about collaborative student learning that I really want to applaud. And even this just yesterday, we saw 3 beautiful papers. Some of the people are here in the audience that endow these different collaborative environments with EDM technology. And within this wonderful group of work, my own bent and my lab's work is to bring together these great models of EDM and kind of bridge the gap between EDM and actually getting students to learn within the classroom environments. So the perspective of my own lab is to bridge this gap and endow agents with the power of combining educational theory with both AI and learning analytics. And the idea is that the AI can use these models to interact with agents. They can generate feedback to guide students in their work. And so I want to stop here for a second and bring about skeptical question number 1, which is, how can we carry out this vision if we don't even know how to teach a single student, right? I mean, look at all of the literature on intelligent tutoring systems. We still have a long way to go to understand how n=1 works. How can we get the group of students to work together using all of these technological advancements? And then the idea is that you can only do this because you pay attention to the fact that there's a teacher in the loop. And in my work, I combine teachers not only when I validate the models empirically, but also when I design our models and apply them to the educational setting. So we work closely with teachers, with the stakeholders in education, and you'll see that in my work later on. And let me raise another skeptical question. In this day and age of COVID, this is the experience that I got teaching Introduction to Probability this year, you know, the black wall of death. And what kind of environment really am I going to, what kind of communication metaphor can I have with my students, right? If I want to get them to study well as a group. And to that, I would say there's a lot going on in the background. And students are doing wonderfully at using this information in the background. They self-organize using social networking sites and other collaborative platforms. They can access vast online learning resources. And they talk a lot amongst themselves. We just don't know about it. Again, let me give you an example from my own experience. I was teaching Introduction to Probability, and it turned out that a few students organized as a group using Google Docs, and they did role allocation. One of the students just copied verbatim what I was talking about. Another of the students copied the diagrams from the whiteboard, and a third student kind of orchestrated everything and facilitated, making sure that everything was in the right order, and they were talking within themselves about how to understand the material. So at the end of the lecture, they had a beautiful rendition of what I was talking about. So if this is what students can do on their own, think about what they can accomplish with a little bit of help, with a little bit of nudge from the learning analytics and the AI side. And so for the remainder of the talk, I'll give you several kind of first steps. These are first steps into getting the collaborative learning vision going. And then I'd like to talk, before I questions, a little bit about the future of AI and EDM, which I'm a big proponent of. And so I want to begin with this beautiful piece of work that I really encourage you guys to learn, to read, from Chai and Wiley, that talk about overt classroom behaviors and measuring engagements. So this is a tool for educational researchers who care about how students interact in the classroom. And they have this pyramid of interaction. The base of the pyramid is what they call passive engagement. And this is simply a student who is just sitting there and taking in what's being said in class. So a student reading the material, for example, that's given to him or her. One level up is a student that's being active, but not generating new material. So there's engagement, there's some kind of manipulation, like underlying something the lecturer is saying, but there's no actual constructive generation, which is the third aspect of this pyramid. So you can imagine a student summarizing, so the level of engagement is higher because the student is producing outputs beyond what's provided in the learning material, but the student is not engaging with others. That's the last piece of the puzzle. That's where you want to go. When the students engage each other, debate, and have a kind of a sufficient degree of turn-taking And that's where the good stuff lies. That's where the cognitive engagement reaches its full potential. And they have a beautiful experiment where they show a causal relationship between cognitive engagement and learning. So they took groups of students and they constrained them to different kinds of actions according to this pyramid. And of course, the students who were interactive, who exhibited interactive engagement, were able to reach better learning gains than the others. So they really have a causal relationship between these different groups. And so my student, Devan Yogev, was really interested in a research question: can cognitive engagement also be a tool for instructors? It's a wonderful tool for researchers, but how can we help instructors make sense of what's going on in their forums? And to do that, he combined automatic classification with visualization in an interesting way. And so we were inspired by the work of Juan Guidall that took the idea of cognitive engagement and applied it to course forums. They did that by making certain changes to the pyramid. You can see that instead of passive, the lower rung of the pyramid is now off topic. So students that talk off topic in class. And they subcategorize some of the other categories, which I won't go into. And so you have this scale now that you could hope to apply to a forum, and it works very nicely. So for example, a student asking a question in a forum should be lower on the cognitive engagement scale because there's not a lot of construction going on, whereas a student that's actually interacting with others and engaging should be categorized higher in the cognitive engagement scale, because again, this is where the good stuff lies. This is where the beautiful collaborative engagement of CSCL lies, and that's what we want to encourage. And then what we did is we took the idea of cognitive engagement and applied it to a context-based forum called Nota Bene, developed by David Karger and students at MIT. Can you see the movie? So the idea behind Nota Bene actually came from the Talmud, which is when you have text that's being discussed in the margins, the students can select a text in the reading material, and then as you can see... What was that? You cannot see the movie, or you can?
The movie's fine. It's being displayed, Kobi.
Okay, thank you. Thank you, Neil. And so the idea, I'll continue. And the idea is that you can discuss in the margins, and I don't know if you guys saw that, but the students could also perform emojis. And this is very powerful because it allows you to talk in context about what's going on in class. And believe me, ask your students. This would help any kind of course. Students, for example, when they prepare for exams, being able to select questions in the exam and to have a discussion about them is amazing. What they need to do now is to go over the traditional forum or WhatsApp messages and look for each other's messages. My students love using Nota Bene because the annotated aspect of it provide context, which is so important. And this context gives you power. So there's research showing that using these kinds of annotated course forums, by the way, there are many others like Hypothesis, and Eric Mazur also has a for-profit, Perusal, it's called Perusal. I'm not pronouncing it the best way. And the idea is that the context-based forums facilitate and promote contributions of students to the forums, peer feedback, and even learning. So they're a wonderful tool. And we wanted to use the idea of context to help teachers understand how students engage in course forums. So here's another example of what context buys you. This is a comment that a student wrote in Nota Bene on a biology course that seems to be kind of constructive. I mean, there's something interesting going on here. And then if you look closely at the material itself, you'll see that the student is merely paraphrasing what's being said. So because of the power of context, they can demote this message to being lower on the cognitive engagement scale. And by working closely with the teachers, this was a prolonged process that used Nota Bene at the University of California, Davis, and they teach Introduction to Biology there with this forum. We were able to come up with this manual decision tree that attempted to minimize the number of questions we need to ask teachers to be able to provide a cognitive engagement label for posts that the student use. And as you can see here, it's quite pronounced. I mean, you have to ask a lot of questions in order to come to the actual label at the end. And this is an example of why it's so important to be talking with the instructor stakeholders while we're doing the research. And what we did then, we collected several thousand messages or posts and labeled them according to the cognitive engagement decision tree in different kinds of courses. And I should say that this biology Biz 2A course at the University of California is an amazing course in that it involves students from various ends of the campus. So both psychology and biology majors need to take it. And it has hundreds of students at each instance. And they have this rule where they do a flipped classroom approach. So students need to read a chapter for each class, and they need to submit at least one comment and by 11 p.m. The night before class. And this is for technical reasons. What time do you guys think most students submit their comment? Approximately 10:59 p.m., of course. So without giving the teacher any kind of ability to being able to make sense of these hundreds and hundreds of messages, we're really inhibiting the teacher's ability to make the best of them before class. And our idea was to try to help them. And so the decision tree had vast advantages to allow us to select lots of annotations. And what we did then is when you plot the students' perspective CE labels on a histogram, you can see some interesting things. So I'd like to point out, first of all, that there's a kind of a unimodal distribution in these two courses. By the way, the physics course was at Harvard. The biology course, as I said, was at Davis. And you can see that most comments are about constructive, but they don't engage other students. An interesting point is that there are very few comments that are off topic. And you can see that here. And we attribute that to the way we define cognitive engagement using Nota Bene. Because this is a context-based forum, then it becomes very difficult to talk about soccer or football instead of talking about the actual mechanism of the course, right? Because you need to select material when you're talking. So you kind of get that for free, that there's less offline and passive engagement going on in the course, which I think is an interesting comment. And so, some other insights we saw just by doing a little business analytics is that low CEs are usually referred to short comments in first posts, while high CEs are usually referred to later in the paragraph. So they come about later in the, students use them later in the course, and they express a lot of student interest. And something really important to suggest to those of us who understand and who know about Bloom's taxonomy is that cognitive engagement is not about understanding the material. It's about engaging with others and making comments that go beyond what's written in the text. So you could say something very wrong, like this student is doing, expressing an opinion about why it's dangerous to consume cleaning supplies. And it's not because they are high in pH. No, it's because they are poisonous. I don't know if President Trump read this notice before he came up with a similar comment. But the idea is you could say something very wrong and still have a high cognitive engagement label because this student is saying something new about the material. So I just wanted to make that clear that there's this distinction. I love the discussion that's going on. It's also taking away from my cognitive state. So I'm kind of going. It's an interesting practice for me as well. So Eran then got interested in automatic classification, and here he tried a variety of hierarchy of features to try to help teachers classify cognitive engagement labels for given posts. So one level of features is just to look at the baseline bag of words approach, like TF-IDF in the post messages, or the length of the post. Another is to look at the context here, so we can compute the similarity between given posts and what's written in the text. So that allows us to see a kind of a higher level of context that's attributed. And of course, we could also look at student-specific comments. So it turns out that students are kind of constant in their CEs, which kind of disappointed me. So there's they vary, but not by much. Each student has this given window of CE, and the student is fairly constant. So you can use that as another way of trying to inform a temporal decision-making model to classify CEs. And the point to take home isn't the results. We achieved reasonable results. This is F1 measures in both courses, but actually where the model got it wrong. So it turned out the model got the paraphrasing comments very wrong and tended to put paraphrasing comments above the cognitive engagement scale as opposed to below the cognitive engagement scale, because the computer was, it was very hard for the computer model to understand when the student was just changing the words in the text, which I found to be very interesting. And if any of you are interested in NLP research, there's a wonderful open question of trying to help to detect paraphrasing. It turns out it's an important open question in NLP. So for any student who's interested. The next step is to take this automatic classifier and to help teachers so that they're not overwhelmed by all of this information at 11 p.m. before the course begins, and that they're able to have this kind of bird's eye view on the material, but also to zoom in on individuals. And in order to do that, we built them this kind of heat map. And I won't go into a lot of detail, but we made sure that the more red you see the paragraph here on the text, the lower the aggregate CE is, and the more we want the teacher to be able to pay attention to that before the course starts, in order to perhaps provide more detail during lectures. And we could see during the course that instructors actually and teaching assistants actually differed in how they use this heat map to inform their teaching. So while the TAs were primarily interested in finding students with low CEs in order to provide feedback for them, teachers were actually very interested in high CEs. They wanted to see where a class were getting good discussion going, so they could use that as a kind of a hook in the class to facilitate discussion. So I thought that was very interesting in how the teachers differed, how the instructors differed. And if you're interested in this, in these findings, you can read my student's paper, where he has a series of semi-constructed user interviews and semi-constructed user interviews with teachers that discuss this point. So I talked on one aspect of engagement, which is the cognitive side. But let me go to the other side of this interesting yin and yang, which is the affective part. So we really care about understanding when students portray emotions when they read material, because as we know from any kind of model trying to understand disengagement in online learning, the first thing that happens is that students become confused or frustrated, and then they leave the system, possibly never to return again. So it really makes sense to look and to understand how they're expressing confusion when they're studying. And the best way to do that, of course, is to use the fact that many of these forms today enable a student to express affect. So it's no longer a hidden variable. They are actually expressing their emotive state while reading. And there's all this work in the learning sciences that tells you that if you're able to pick up on the students' confusion ahead of time and resolve them, you've kind of completed this interesting cycle where the frustration is resolved. It actually leads to better learning. And this is exactly what we want. We want to keep these students in the loop. And so emojis are commonly used in Nota Bene. There's a kind of series of 8 predefined classes of emojis. Some of them are, they can be roughly divided into help seeking and into assistance seeking, as you can see. And students use them. I mean, we analyzed 65,000 posts, and over 40,000 of them had hashtags. And students use a lot of them. So over 60% of the students use at least half of much of the emojis. That's super cool, right? Because you can help to understand what's happening in the student's mind by looking at whether the student is confused. And my student Shai Gelel was interested in trying to understand what's the relationship between what the student sees as confused and what a teacher sees as confused. And also, can we help teachers classify, just like we do with the cognitive engagement, and help them to detect confusion even when there are no hashtags? So can we kind of generalize from the information that we're given with the hashtag to help teachers understand what's going on without hashtags, which is of course what usually happens in traditional course forms. So to do that, again, I can't emphasize enough how important it is to look at the educational studies literature. And for all you students out there doing wonderful things in EDM, if you take one thing away from this talk, look at the educational sciences literature. There's a lot of important information that can help us. So for example, Shai discovered that there are various forms of confusion that we should be paying attention to. And so for example, a student could be seeking information consciously, but a student could also be stating something that is incorrect, even though that they do not themselves know it. And you can see here are some examples that we selected from the text about this. There are various types of confusion, and that has to be reflected in the kind of labeling rules you're going to give teachers. I won't go into the details. I'm happy to point you to the paper where we created, just like for cognitive engagement, a kind of a decision tree for the teachers that helps them label confusion. And so the next thing we wanted to do is to compare how posts that students label as confused compare with what teachers see as confused. And the naive way to do that is just to say, well, here's a deterministic rule. Any post that has hashtag confused on it should be considered as a confused post. Here's an example from the text. But doing some analysis and some computational thinking led Shai to also consider another rule. So there are obviously points in time where students ask questions that express confusion, but they don't express it explicitly. So he came up with another rule that says, if and only if there's some assistance-seeking emoji being used and no other hashtag, I will consider that to be a confused post. And the first thing we did is we took 150 posts from the Nota Bene course. We divided them into two groups, one that's being labeled by the R1 rule, one that's being labeled by the R2 but not the R1 rule, and one is a control condition, which was randomly selected from the forum. And then we looked at how teachers aligned with the selected confused posts in each of these groups. And as you can see from these results, a large degree of the posts that were measured by Rule 1 actually did concur with what teachers saw as confused, and also a large degree of what was measured by R2 and was not measured by R1. So I want to emphasize, these posts would not have been considered to be confused if we only used the naive rule, but by looking at other assistance helping tags, you were getting closer to what teachers themselves were reflecting to be posts that exhibited confusion. And so the next step in this research proposal is to try to help teachers automatically infer what constitutes a confused post. And again, to do that, we used several hierarchies of features. And we also used BERT, which is a wonderful pre-trained deep learning model that is being used excessively now in various kind of peripheral communities to NLP, from education, for example, to biology and health. And I really encourage you to read some papers about that, and I'd be happy to suggest them to you later. But Shai was able to achieve a good performance using this pre-trained deep learning method. And again, the most important thing is to see where the model was getting it wrong. And I'll just remind you, CF2 were all those instances where students were stating errors without knowing it. So they were actually confused, but they didn't know it. And if you think about it, this of course is where the computer model gets it wrong, because the computer model also doesn't know that the student isn't getting it. This is what you need the teacher for. And the teacher was able to understand when these confused posts occurred, but the computer model was not. And again, this is a very interesting aspect for future work, and it requires richer models that are able to track what the student is understanding in terms of cognitive concepts. And the last thing I will say about these emojis is that it had this wonderful adventure of talking and surveying what students would like to be able to express when they read materials. And look at that. This is the new set of emojis that are currently being deployed in the summer session in Davis. Look how wonderful the students are. So they're not only interested in conveying emotions that have to do with what they reflect on, but also with things like, does this help me make connection with other parts of the course? How does this connect to a learning goal? This is amazing, right? Because most students don't bother with considering the learning goal, but this actually helps them to say, oh, okay, this post actually refers to a learning goal. They're told what the learning goal is for each and every class ahead of time. And they're, of course, also able to ask to discuss. And again, it's important, ladies and gentlemen, to be able to interact with the stakeholders. And that allows you to really advance your research and to understand, because this is now going to enable us to have a better idea of how students learn during the course by having the students label the posts rather than to have to ask the teachers to do it or to have to hire people to do it who won't be doing it as good as the students. So again, this is an important comment about engaging with the stakeholders. Okay, so I talked about this kind of large group collaboration, right? Where students are interacting in an asynchronous way, and they're using these the forums. And what I'd like to talk to you now about is smaller groups of students. If you recall, I told you that the CSCL community favored 3 to 4 students working together. And what I'd like to do here is to try to help teachers being able to monitor these group of students in parallel. And you can imagine taking a class of 30 to 40 students, dividing them up into small groups, and hoping that the magic takes place by allowing the teacher to facilitate what the computer is doing. And this was exactly what we were trying to do with our partners at the Hebrew University, Baruch Schwartz and his team. The idea was that students would be working in parallel using the GeoGebra, and there would be kind of a classroom context. So the teacher would be involved, but as a kind of a facilitator, and only intervening when ultimately possible. Only when the groups need assistance, then the teacher would be able to intervene. And the teacher would be making that decision, not the computer. And so we interviewed teachers and asked them, would you be able to support student teams working in parallel? And of course they said, well, there's no way I could do that. Either I would have to treat each, I would do kind of a round robin between the groups and not give any of the groups the attention that it deserves. Or I would need to pick one of the groups and spend all of my time with them and totally abandon the other groups. And so here we were inspired by the work of critical moments, which some of the CSCL community is looking at. And the idea is, what are the cognitive states of the group as a whole when they're interacting that require a teacher's assistance? Can you identify these states, and can you report that to a teacher? So the idea is to try to understand when these critical moments happen. And there's a wide degree of critical moments. So for example, one of the students is making an important claim and is being ignored, or the group is idle, or bullying can occur. All of these are kind of moments which require the teacher intervention. And we built this system that would try to do that automatically. The system is called SAGLET, System for Advancing Group Learning and Educational Technology. And we're first doing baby steps by only looking at 3 very simple critical moments. So are the students on task? Do they have technical issues with the software? Because there was a lot of technical stuff going on, technical problems going on with VMT. By the way, it's become much more stable since then. And whether the students are off task. And the idea was that the teacher would present a geometry challenge in the classroom. The challenge would be loaded into the VMT software, and then students would be allocated to several groups. So each group would be logged on into a different virtual VMT room, and the groups can discuss and solve the challenge while performing certain operations. And the teacher has this bird's eye view, air traffic controller, watching the SAGLET control GUI, and can visit any of the rooms according to her or his wishes. And the system is providing alerts to the teacher, as you can see below, in form of all of these little cues. So a wrong solution, whether something is going on task. And as you can see from these types of alerts, for some of them, you don't need any kind of sophisticated computational methods, right? To understand if the system is idle. You can do that very easily just by observing the clickstream. But for teachers, that's a very important piece of information, because if you have only one teacher, you need to be able to help him or her understand what's going on. And that's why we invested a lot in the visualization. So my now postdoc, Avi Segal, did a lot of work in designing the evaluation, the visualization method here, where you can see that we kind of prompt the teacher by coloring the room where there are critical moments, and we used color tagging to help identify what's going on quickly. And we did an online study where teachers were able to use this tool to understand and to decide when to intervene. And what's amazing is that the teachers were able to use a wide variety of intervention types that I'd like to show you. So we divided them into 5 different types. I'll just focus on 2 of them. One of them is we call social validation. So what you're looking here, they had to do a kind of construction open-ended problem. It was to construct a quadrilateral whose diagonals intersect and form 90 degrees. And so they thought the correct answer is a kite. The teacher said it was wrong, and then posed also a question to them to help them to kind of nudge them into the right direction. Another important piece of intervention was argumentation. So here they think it's a square, but what the teacher is doing is showing them that it's actually not a square. It's an unidentified quadrilateral, and in this case the teacher wanted the students to understand that an important concept to help them along in the solution process. And so I'm going to conclude this part of the talk with a movie, and I think the sound isn't working. So the movie is in Hebrew because this was all done using Hebrew NLP. It was picked up by the Channel 10 news agency here, and I'd just like you to be able to kind of get an intuition about what was going on in the classroom. Can you see? Let me know in the chat.
על כל אחד מכם לרשום את התשובה שלו בחדר הצ'אט. קדימה בהצלחה. תרומה זה כיתה של 20 בנים ויש תרומת הלכות, אבל כולם לומדים.
בבית הספר אהבת ישראל שבבית שמש אולי לא יצטרכו בקרוב מורות עם עיניים בגב. הבינה מלאכותית עוקבת אחרי העבודה של התלמידים בכיתה, והמורה בודקת את התשובות על המחשב ומתערבת רק במידת הצורך.
אתם רואים שיש לי פה סימן אדום? זה אומר שיש פה תשובה שבויה, אז אני עוברת פה על הצ'אט לראות את התשובות שלהם ואיך הם דנים. הם דנים בין עצמם, מפתחים שיח. אני יכולה לתמוך בהם, אני יכולה לכוון אותם, אני יכולה להעיר להם על תשובה לא נכונה. אבל ברגע שיש לי התראה, חבר מהקבוצה לא עובד. אם הוא לא עובד, אז יש לי התראה שאומרת שזה לא בסדר, ואז אני אומרת לו, גלעד, תתעורר, תתחיל לענות.
אני לא חושב שמחשבים יכולים לבוא במקום מורים, אני חושב שהם יכולים לבוא ולהעצים את המורים. אני אתן לך דוגמה אישית, למורה שלי בכיתה א' קראו מאלי, ואני לעולם לא אשכח אותה. והכריזמה והאינטואיציה והתקשורת הבין-אישית בינינו מאוד השפיעו עליי.
I should say my mother called me after this and she said, your first grade teacher wasn't called Mali. What are you talking about? And before I go on, I just want to tell you what for me was amazing about this research was that teacher, whose name was Mili, what was so amazing about the way she intervened was also when she decided not to intervene. She said, oh, this group is completely in the wrong direction, but I love what they're doing. And I'm not going to intervene because the processes that are going on, both cognitively and socially, are very important right now. And again, this is a wonderful kind of testament to why we really need the power of AI and computers and learning analytics to be coupled with a teacher in the loop, which is actually how we called this paper from AIED. And I should tell you that what we're currently doing is, just starting next year, is trying to take this approach into Bedouin schools and to try to help them also with the understanding effect. And we're still figuring out about how to do that because we're obviously constrained by COVID regulations. So let me conclude by kind of doing a quick recap of what we were talking about in this keynote. So the big vision was to use EDM and AI as facilitators of collaborative student learning. We want to bring the groups into the good stuff zone, right? Call it what you will, zone of proximal development, zone of high engagement, the zone where the magic happens and where the learning occurs. And for that, we need to be able to understand not only how students learn using computational methods, but also connect to the stakeholders to understand how teachers see the pattern. We don't want to overwhelm teachers. We want to augment their ability to help students understand. So we don't just want to dump technology on them. And the other issue is it's very important to look at the literature from the learning and educational sciences. And I can't emphasize this more, how much I learn and how much I'm empowered by when I have discussions with educational researchers and when I read the literature. And if what I've told you really turned you on to any of these vision points, then I want to suggest lots and lots of great open questions that are out there. Some of them are quite low-hanging fruit. So, for example, how to allocate the task that best suits the group's needs, and how to construct the group. So if you recall, I told you that when I was in school, it was important for me to find someone who is a little better than me and a little weaker than me, because that made me feel good. So how can we do that automatically using computational method? How can we should we care about the incentives? So how do we keep students motivated while they're working in the group, and making sure that they don't lose their ability to have fun, and we don't want to get them to disengage. That's a very, very important aspect. And finally, how do we make sure that we preserve student privacy and that our models are fair while still providing them with technological support? And this is a very, very important point. And I know Shayan is here in the audience, and I'd love to hear his comments about this. So I'll give you an example. We were running a session in Haifa and in a school, and there was we were giving groups to solve mathematical questions, and this 8-year-old girl got a question that was too difficult for her, and there were all these scientists around, and she got really upset and she cried, and that was very, very difficult for me to see, because I didn't have enough information for how 8-year-old girls study math, and therefore I wasn't able to give that student the right kind of exercise to do. And you can talk about why there's far less data of girls solving math questions than of boys. I won't go into that, but the fact we have to be aware that these demographic aspects are going to affect our models, and be able to integrate that into the way we reason about models. And so with that, I'm going to conclude. I really want to thank my wonderful group of students, both in Ben Gurion University. You can see us climbing, this is our last lab hike, climbing one of the peaks above the Dead Sea. And on the right, you can see Arthur's Seat in Edinburgh. And I will open for questions. Thank you very much.
Thank you so much, Kobi. As Kobi said, he's open for questions. Kobi, if you want me to help with moderating, let me know.
Yeah,
otherwise,
please.
I'm happy to let you.
Can you help me?
Yep.
With maybe we can
do that.
Start with the
Looks
questions
sorry, go ahead.
that are already there.
Mm-hmm.
Yep. I didn't see, there was a little bit earlier on if people wanted to re-ask. Maybe if people posted earlier, if you want to re-ask in the chat or raise your hand. And then I think Neil has his hand raised. If you want to go first while people are doing that.
Kobi, this is a great talk, and I'm sorry if actually we distracted you with the chat. Don't actually worry about the chat. We should bring it back up. But I just wanted to say, I love the fact, and I'm inspired by your work. So this is less of a question and more of a compliment that actually, but I see a connection. Like if there's one thing we do well in assessments is getting teachers to talk about things like a common wrong answer. Exactly. And the Bente system seemed to do a good job of letting kids self-express frustration or confusion in like the right place in some places, so that you can then more easily make it possible for the instructor to realize lots of kids are getting confused here. And it just seems like a really good way of connecting the EDM community in ways that are beyond just normal intelligent tutoring systems where everyone's like solo doing their thing. So I just want to say that seems really important. I actually, when I look at it, I'm trying to figure out what I can do in the math context. 7th grade math classrooms, we don't send kids to go home and read their textbook and then make comments on it, right? Like that's not what you do in 7th grade math. And so I'm wondering what's the crap that we could do to better help them. I don't know if you have any thoughts on that, Matt.
So first of all, this idea of annotated forums doesn't have to be on reading material. It could be on a movie. So for example, choreographers use Nota Bene to give instructions to dancers. They just, they put the stickers on the movie itself. It could be any kind of content. And you could definitely envision, I think, something along those lines of media being presented to K-12 students, whether working at home or as a group.
Yeah, like figuring out how to actually let them to do that, and in such a way that actually helps them do that to help a bunch of kids all at the same time, right? Because there's the teachers, the limited attention span of the teacher. Like, I just want to say, it seems so insanely important in this COVID times. We're probably going to have a lot of kids that are going to zone out, right? And then we're going to blame the kids. But if we could figure out how to help the teacher detect some of that earlier so they don't lose focus, seems super important.
Very important, and also very important in today's online world. So students zone out much quicker with Zoom, I can tell you that.
Thank you.
Wow, we have some great, I see pointers here from lots of people. Thank you.
And it looked like Cheyenne asked about work on group formation. I think some people are providing pointers on, but I don't know if you have anything to suggest further, Kobi.
So there's a lot of work on group formation in strategic and also in HCI about how to build teams that work together. I don't know of work in group formation for educational contexts, and that's why I recommended it.
I have a question, Kobi, if I just typed it in, but I can ask out loud if that's easier.
Please.
Ken Kadinger.
I can.
Thanks for a great talk, Kobi. It was really wonderful. Lots of wonderful examples. Actually, I'd love to see more of the geometry one. But my question's more general. Doing effective collaborative projects and classroom dialogue is really so important, and it's really hard for teachers to do. But it's sometimes, I think, portrayed as instead of like deliberate practice on fundamental skills, and it's sometimes considered in addition to fundamental, more deliberate practice on fundamental skills. Do you see it? How do you see that interplay? Is there room for both, or should we be, and you could relate it to ICAP, for instance. Like sometimes there was some dialogue in the chat around maybe sometimes active and interactive are good, even if it's not constructive, as long as there's other times when it is constructive and interactive.
You're right. So I personally think that this emphasis on using school to instill cognitive skills is wrong. I mean, in the real world, the soft skills matter very, very much. You need to be a good team player to make it in this world. And the fact that we're so obsessed about the standardized tests and getting students to work individually. By the way, it always amazes me when students start doing their masters. And I'm sure it happens in CMU as well. Like in the beginning, they don't get it. What, I can work with other people? It's okay. I can have a thesis and work with other people? Yes, of course. You've just been indoctrinated to working by yourself all of these years, rather than trying to form the best group and make the magic happen that way. And therefore, I think the answer to your question is in addition to. I think it's an important. We should be doing more of that.
Yeah, but not abandoning fundamental skill practice. Actually, earlier in your answer, it sounded like you were saying instead of. But
I'm not an extremist. I don't think it can come instead of fundamental skills. But right. it should come in addition. And then, of course, that raises the question of what can we give up? And by the way, there's a reason, right? And also it requires teachers to be much more engaged with the students, and teachers are overworked and underpaid. I mean, this is a very big problem.
For sure.
Yeah. Jack?
Yeah, thanks. Hakol Mitsuyan. I looked at your talk in terms from the perspective of scale up and the cognitive load on the individual teacher. So the overall question is basically, as you scale up further and further, what are good divisions of labor between what one teacher assisted by technology can do and what autonomous technology can do? So for example, the heat map I viewed as a way to reduce the cognitive complexity for a group of arbitrary size to see where the teacher's having trouble. For the thing that we saw later, where you have a teacher in a classroom with a small number of groups, who doesn't have eyes in the back of her head. The technology can identify issues in real time and call her attention to them, but she still has only seconds, if that, to understand enough about the context to know how to intervene. So as you imagine that one class getting bigger and bigger and bigger in terms of the number of kids and the number of time zones in which they're operating, what do you see as a good division of labor between what you can do to accommodate the teacher's limited cognitive bandwidth versus do at scale automatically, for example, Carolyn Rosé's automated methods for facilitating small group discussion, including the sort of soft skills that you mentioned?
Yeah, so those are great papers. You ask a very difficult question.
Of course.
And the short answer is I don't know. I don't know what is the optimal division of labor. I think it's highly dependent on the teacher. And some teachers are very good at being constantly monitoring and resolving these alerts that they're given. They treat it almost like a game, and they're waiting for the next prompt, and they really liked it. Well, other teachers didn't. And
sure, but how many of those teachers could handle a class of 1,000?
Yeah, so of course, a class of 1,000 and one divided into groups of 3 or 4 students, you're talking about 200 rooms. There's no way a single teacher can provide support for that number. I think the magic numbers lies around 5 to 7.
Right, but there are MOOCs that are way larger than that.
Right. Yeah, so we would need to work very hard at both increasing the number of staff that's constantly supporting these MOOCs. Look, some MOOCs operate completely automatically. You're just not getting that kind of support. They're automatically graded, right? And I think there's like a very nice continuum between the amount of support you want to give the student and the amount of computational crutches that you're giving the people that are running the support. And right now, as you saw, what I presented today was very few. We're still baby steps in providing those crutches. There's a lot more to do.
Still very cool.
And this maybe relates to Hong Shin had a question in the chat about self-paced online learning and thoughts on facilitating collaborative learning in that kind of educational model.
Yeah, but so I love self-paced learning, and I love to be able to send students to learn a new topic by just giving them a link to an online course that I can then talk to them in a few days, and they've done the course. I mean, it's beautiful, but it requires a very different kind of student.
Yeah, Tiffany, it looks like, has her hand raised.
Oh yeah. We did a study comparing some teachers with students collaborating, and one thing that one of the teachers did, this was learning programming, and they assigned some students who did really well on the first part of their programming, and then later when they were doing collaborative work from other classes to come in and be the assistants to kind of do that low-level help. So, and then when we looked at sort of the effectiveness of the teachers, the one that was the most effective did what your teacher in your video did, which was you know, seeing what the interaction was going on. So I love your system. I think systems that help teachers do that thing that they love to do, which is to really see how the groups are doing and like inspire them and push them to do more, is really excellent.
Yeah, and I think you guys raised very important questions about how to make sure about kind of this trade-off between cognitive load and how teachers, instructors, different stakeholders relate to this idea of collaborative, because at the end of the day, it requires a lot of effort from people. You know, the best tool you can build is still going to require a lot of effort. And I just have to show you, maybe before we finish, there's like a website we built for the people doing the connected worlds. I'm not sharing my screen. And even that, let me see here. this desktop. Okay. Can you see my, so this is for that project with the ecological simulation. And actually I used this domain to investigate open-ended problems in AI, like interpretability. It's actually a great domain to look at interpretability. Nick has a paper in ICHKAI on it. But if you look at an example visualization, so you're going to be, this is an 8-minute video of water. You see, these are the logs that the students are doing. And this is the water going into the various biomes, and this is the fauna and flora that is blooming. And here you see the output of this temporal model that Nick built that is trying to segment what the students are doing on the floor into human interpretable pieces. And the idea was that the teachers will be able to look at each one of them separately. So these curves are just water movement. So for example, the model decided that this is a independent segment because I guess, I don't see the legend here, but I think this is water going into the jungle and now it's reaching its peak and it's starting to go down. So the computer decided that this is an interpretable segment. And again, we saw that it takes a lot of work even understanding what's going on here. You have to give all this information. So there's a lot of important considerations into building these tools that have to do with cognitive effort, with visualization. So you need to do good HCI, and you need to understand what teachers are capable of doing and not to overwhelm them. And we're just at the beginning of this process.
Looks like Neil, you've got your hand raised again.
Is Node Bene a good system to actually work with as researchers? Did you guys build this? Like, are other people able to use this and build upon it?
Definitely, it's used by hundreds of courses. It's very.
You don't own it. You don't own it, but as like if it's, I should think of it like Piazza.
It's open source. There are two open source content-based forums. One is called Hypothesis, and one is called Nota Bene. Those are the main ones. Nota Bene is the academic one.
Wow, so it's actually open source, so other researchers in this community could go.
Yeah, I could
download the code, run it with their own courses, and augment it and do. Cool.
Kobi, I'd like to suggest a unit for measuring your research progress, namely the number of eyes you can install in the back of a teacher's head.
All right. I think we're just about out of time. I don't think I've missed questions in the chat that were directed at Kobi, but things are going by quickly. So if there is a last question, feel free to raise your hand.
These are also amazing comments by all of these wonderful colleagues. I need to select all here very quickly.
Yes.
You can
You're a great dialogue leader, Kobi. You got a lot of interactive, constructive activity going on in the chat. It's really great. Thank you.
My pleasure. My pleasure. But, you know, I have to say I'm a little sad because I was just reminded how much I miss everyone.
Yeah, right.
Would absolutely love to see you guys.
Yep. Yeah, have dinner together and all the rest. Yeah.
Excellent. Well, let's...
Coffee break at least together, right?
Exactly. We can coffee break together. I will leave this open for anyone to save the chat, etc. And I think I will get a copy of the chat that I can attach to the session. But just join me in virtually thanking Kobi one more time. That was a great talk. Really appreciate it.
Thank you very much. Thank you.
Right.
I just emailed you the chat too, Kobi.
Excellent.
Thanks, Neil.
So since nobody's talking, Kobi, have you done, I guess the videos you show are with children. So we've been doing some work recently trying to help figure out how students, like slightly older students, high school students, and introductory college students can collaborate online, like
Wow.
in programming. And we've done some experiments where we actually took the programming environment where the students are, collaboratively constructing a code. And well, we did this in middle school. We actually tried out driver navigator pair programming where people were taking turns during construction. And then we also did what we called a puzzle technique, where we actually only gave part of the tools to each student. And that actually seemed to make people have more fun when they were doing their collaboration. So I really love that you highlighted fun and motivation as important parts of collaboration, because I think they're critical. And people, so the cool thing about the study we did was after students experienced the different ways of collaborating we were giving them, they were given another task where they could choose. And about 60% of the students chose to use the puzzle model, where they could, they couldn't have all the blocks. They had to ask people for parts that they needed to make stuff. 40% chose to be able to have access to all of them, but that's because they didn't want to collaborate. But I think doing things that make people collaborate but don't even need AI, I think are really fun.
Yes, I completely agree. So you think it was the collaborative aspect that the students like, or the fact that they thought that the puzzle kind of gamified the experience a little?
I think there's kind of both, right? I think that if you're not given, well, there's some research at, I think it was Urbana-Champaign, that was looking at trying to build in a system to tell people how to collaborate and kind of give them guidance while they were doing pair programming. And they showed that they didn't improve the performance. And I think it's partly because of the cognitive load of keeping track of what's this suggestion from this collaborative agent and how can I be a good collaborator? And you have to keep track of that. But if I have some blocks and you have some blocks, just making an analogy with kids is we're making something with Legos. I've got all the red ones, you've got the blue ones, and we're trying to make a face. I've got to get some other color ones because I can't make anything interesting with mine. So I think it's sort of you don't need a lot of cognitive load to sort of make more collaboration happen.
Do you have a paper on this, Tiffany?
Yeah, there's a paper in SIGSI 2020. I'll post a link.
And this issue of cognitive load keeps coming up. I realize now that this is a very important aspect. Because I haven't done any actual modeling of cognitive load.
We did some cognitive load modeling, but the only measures we've used are self-report, and there's different scales, and it's quite difficult to get, I think, any data that's good on cognitive load.
I mean, you don't want to have to put people under one of those helmets. Although there are more and more people doing that. But I don't know if in education, if there's I know a lot of work in cognitive science trying to measure cognitive load in different problem solving. Tasks. My student was doing that with IQ tests, solving Raven tasks.
Yeah, the cognitive load thing is interesting too, and sort of the thing I was noticing that it sounds like kind of Tiffany's puzzle tool, and also with when you were showing the thing with GeoGebra of having the system that helps students kind of keep track of everything together versus, I don't know, the experience I feel like of a lot of my students in this last term of, I'm putting them in some tool that is not super designed to help them keep track of their collaborative roles. So, they're in a Zoom breakout room together, or they're on a Google Doc or some shared coding thing, and how much more difficult it was for them to collaborate in those environments versus what they were used to doing together.
Wow.
And trying to think about, how we can build systems like the one you were showing, but that aren't required to be specialized to just that kind of GeoGebra thing, but sort of more generally facilitating a teacher keeping it on multiple groups.
I call that arenas. So it's you want the arena can be very complex, right? Or it can be very simple.
Yeah.
Look what people do with Google Docs.
Yeah. Yeah. No, we've had people also, we used something called Replit for pair programming this term. And it was interesting how they did that differently when they were actually both able to, it's kind of like a Google Doc for code. And some students actually were kind of able to be more productive in collaborating on that than when they did the traditional pair programming of being side by side, because you could see where someone else's attention was in a different way than just like either pointing at the screen or somebody kind of, you know, just looking at the same thing. So it's kind of cool.
So is programming a good collaborative activity?
We do all of our first and second term courses with lots of pair programming, and we continue it throughout the curriculum. So it seems to work well.
And what,
we're doing it.
Yeah.
We're doing it in K-12 for integration of computational thinking and programming into science and math classes. And for high school computer science principles classes, which is a college prep course in the USA.
Yeah, I know about your work on computational thinking. That's great work. But I didn't realize the students were doing it collaboratively. And they're also graded collaborative? I mean, they're graded the same?
Grading is by the teachers. And actually one funny thing is I work with Dan Garcia, who was, you know, sort of a evangelist for the Beauty and Joy of Computing class. And he actually taught a class and made the kids do everything collaborative. But at the end, a lot of the students didn't do so well on the exam. So most teachers mix it up. So most teachers say, do this one individual, do this one collaborative, and they mix it up so students get practice. Like that, well, like what Ken was saying, actually sometimes they need to go do some individual skill development.
Adam, I'm not sure if you're trying to break in, but feel free to unmute yourself and break into this conversation. We're just informally chatting.
I wanted to break in. So I guess, and this ties to some of the conversation that I was having with Tiffany in the chat. It seems like, Tiffany, you were saying that you've done that peer mentoring where you had other students coming into a classroom to be mentors for, you know, other students. And what I was kind of trying to think about is like what would be the logistics of doing something like that at like a university. So, you know, we're both at NC State. Like, how could we require students in 216 to help be mentors for 116?
Yeah, it looks like Carolyn Sealfon, I'm not saying it right probably, posted a link to something called Learning Assistant Alliance. There's a couple of different ways. Like at Berkeley for the BJC class I was just mentioning, they actually make a course for students after they've taken that class. They can register for like a credit hour to go be an assistant in the class, the next version of the course, which I think is a great way to do it because credit hours are something that we can give for free for us.
Yeah.
And they pay money to get credits to do that. And then students can help new students. And then at Berkeley, they hire from that, they hire TA. So after a student has taken the class and been an assistant, then they can be hired as a TA. So I think we should make these graduated methods. But I think one way you can do it in a class for 2 or 3 is to use peer-led team learning, like Beth Simon's work, where you actually have like collaboration in class, where you have peers in different roles.
The reason why I'm concerned about like in-class peers is you've got that delicate balance of trying to help someone who might be a lower performing student, but then you also have to deal with your own learning tasks and learning objectives. And so I think that the problem could get confounded because of you're trying to do these 2 separate things. But I like that idea of like making a course, literally turn it into a 1 credit course, because I think that that gives teachers the eyes in the back of their head that Kobi was literally talking about. Here are people who are your eyes, and it also would benefit those students because that's the learning by teaching theory.
Well, I think it also builds those social relationships between the classes, and it also has those concerns. Like as a professor, I'm like, I don't care which learning environment you're using for programming, and I don't care which, like, that you can't find the link to it. Like someone else can tell you where that is. right? So and so I have no patience for that as a full professor. I've been doing this for years and years. I'm like, I have a PhD in computer science. I will figure out how to get the software installed. But novices, that's like a major barrier, right? So if you have students who come back from the previous semester, they're like, oh yeah, this was a pain. Here's how I solve that, and here's how you find these things. And they care about the issue way more than me, because I'm like, I want you to get the learning objectives. I want you to know what an algorithm is, right? And I don't care about that. You just figure that out so we can talk about this thing I care about. And the students, they empathize with each other. They can say, oh yeah, that's really dumb. Let me help you with that.
And I think they just like you were saying, they get a vested interest in the community as a whole. So someone in the CS2 course now has a vested interest in the CS1, and it builds, it strengthens the community of that. I'm still thinking of, in the college level, but it would strengthen the collaboration in the department as a whole, because you're having to work and you actually care about the progress that you're working with.
There's one other project that I know about that I'm not part of that's actually has another way of collaborating between classes. It's called Bridges, and it's a project funded by NSF, the National Science Foundation, at UNC Charlotte, and I'm going to post a link to it. It's like 2 classes are designed like where sophomores and seniors work together. So I think seniors have to make software and sophomores have to make some requirements for it or something. So they actually have parts that they're learning in the 2 different classes, and they have deliverables that kind of interplay in between the 2 classes. So I think there's other cool ways to do this kind of stuff. They take more work.
Yeah.
There's also a paper I'll try to find and post that Michael Eagle and some other people worked on building a dashboard to show which students ought to help other students in the same class.
Oh, yeah. This is a lovely conversation. I'm going to have to stop this Zoom room shortly because I have to go to a different one. But Kobi, I just want to thank you again for your talk and all of you for great conversation. And hopefully see you all at EDM somewhere exciting that isn't our houses next year.
Yeah, I'm so sad not to be in Morocco. It would be super hot, but it would be so fun to see everybody.
Exactly.
I second that, definitely. Anna, you're doing a wonderful, wonderful job with this conference.
Thank you. I'm trying. So, all right. Well, thank you. I'm going to end it, but I will post this chat. I believe it will save for me, and I will copy and paste it as well. But thank you again.
Excellent.
Amazing
Bye-bye.
talk.
Great. Yes.
Thank you, guys. Bye-bye.